Today we will see this topic named as RTOS scheduling. So RTOS stands for real time operating system, and there we have to say today this rate monotonic scheduling. So what is actually rate monotonic scheduling? So here you can see this is just a static priority scheduling algorithm used in RTOS, that is real time operating system, and it mainly focuses on a task which has a highest priority. Means if we will have multiple tasks in our problem present, and there out of those tasks, if some task may have a higher priority, so it will get a first chance for execution. So how does it works, we will see with the example. But before that, here you should just know first few features. Like, so the first feature is here, priority assignment here is inversely proportional to the task period. Means if you will have lesser periods, you will have higher priority. So you can simply write here one thing, like if you want to say something as a priority, so that priority will be all the time opposite of, you can consider, or inversely proportional to your period you can consider. So 1 by period you can consider. So period like this. Please remember this one because this is important, something that we need to use. So if some problem has a higher period, so definitely the priority will be lesser because they are inversely proportional. Please remember this word. The next statement is here preemption. So as I was telling here, if you will have some higher priority task, so it can stop any currently running task which has a lower priority. So that is also important that we need to understand. And the topic is really easy, you will surely understand this. So we will go here with a sum of note that we should just know about RTOS, rate monotonic algorithm. So I will just go here. The first note that you should know here is, as I was telling, I was telling here, period is what inversely proportional to the priority. This thing you should know very first. Like if you are telling like you have higher period, so priority of that task will be definitely less. So please remember this one as your very first note. Then next to that, if you are going to consider something as period, something as priority, just let me remove this. Period, we have few terms as like period, priority, and one term again we have rate. I will talk about it, no issues. These three terms we have. These three terms. So here please remember one thing, if you are talking like you have a higher period, let's say, or the period is, let's say, lower, here we have, if the period is lower, so in that case the priority will be definitely higher. Okay, this is, let's say, lower, period is lower, so priority of that task will be higher. Please remember this. Okay, and the rate will follow here your priority. So what is rate, that also we will see. Okay, this thing you should know. You can consider this again, it's vice versa also. So you can say like, if you will have now your period in increasing order, let's say period is increasing, now a period is high for any task, so definitely priority will be less and rate also will be less. Please remember this both. With examples surely you will understand. Again I am telling you. So what is here rate first? So again please remember few definitions again, like how to insert, okay, text box. So first thing I will just talk about period. So what is period actually? So like you can simply consider this as a interval, any interval of time when a particular job repeats itself. That is what, that is just a period you can consider. Any interval of time whenever some particular job gets repeat itself, that is a period. Okay, I hope it's visible. Next, again, one more thing that you should know is like here, let's say every task executes only once in its period based on execution time, that you can consider E. We will have those terms given in problem. So please remember all those things, because whenever we will be talking about any problem, which you will see here on the next slide, here you can see like we will have something as period and something as execution time. Also they have given you here the priority as well, but we will see like how they are telling the priority is high for T1, uh, the priority is medium for T2, and for T3 the priority is low. How they are telling? We have some assumption with us. Like I was telling you, if you are calling some task as a task to be depend on a priority, so here you should concern this factors. If the period is high, then definitely priority will be low, and if the period is low, then the priority will be high, like this. So here also you can simply consider, out of this three tasks you should check like which task has a least prior your period, which task has least period. So this is 4, this is 6, and this one is 8. So you know that out of 4, 6 and 8, the task having 4 period is the smallest one. That's why its priority is high. So lower the period, priority will become a high. Here the terms are moderate for task T2, that's why the priority is medium. And here for task T3, the period is highest, that's why priority is lowest. So they are inversely proportional. So you can write like this. One statement or one conclusion you can write like here, the task T1 will have highest priority, then T2 will have a lowest, middle we can consider, and T3 will have a lowest priority in terms of their priority level. So please remember this one. Okay, so in terms of priority you should just remember this one, like the T3 will have highest priority, T2 will have moderate priority, and T3 will have a lowest priority. So here also you can see like I have written somewhere like the higher priority task can preempt currently running lower priority task. So we will see like how it will happen. Here now we got like which task has the highest priority and which task has a lowest priority according to this example. So we have here some three tasks given. They are asking to draw Gantt chart. So this kind of problem may ask into your exams as well. So we will see like how many uh, like values or how many columns we should have into our Gantt chart. So first I will simply draw here those tasks. The task is T1. Let me just increase here the size so that you can read this. We have a task T1 which is consisting some two values. We will be consisting every task in such a way that you will have here some period and execution time. So P and E means P stands for period, E stands for execution time. So I'm just writing P is your period and E is execution time, like this. So both of the factors you should know, and based on that we will see like what are the three tasks. So task T1 has what? If you will check this problem, task T1 has period 4, execution time 1. So 4, 1, 6, 2, 8, 2. I will just write 4 1 4 1. Then T2 has 6 2, and T3 has T3 has 8 2, like this. So these three tasks we have, and we know that now which task has highest priority. This T1. That also I will just copy here. Okay, so you can just keep this also with you, because here based on this assumption we will going to consider now the Gantt chart. But how many cells your Gantt chart should have, because we don't know like how many cells you should have as of now. So what you can do is you can simply just go and draw that Gantt chart. So how you can do? So for that again I would just tell you, for drawing Gantt chart you should simply consider the P term of every task. So P is what? That period. So, and for that all the P terms you should take its LCM. Okay. So to find LCM of this, what you can do is, I will first take 4. So 4 I can write as 2 raised to power 2. 2 raised to power 2. Or 2 multiply 2 you can write. Okay. So where is cap? Okay, I can't find this. So you can simply say 2 multiply 2. 2 raised to power 2. That is 4. The next task, if you will consider, this is for what task? T1. Next task, if you will consider T2. So for T2, what is period? It's a 6. So 6 I can write as 2 multiply with 3. And T3 I can write as 8 equals to, you can write 2 raised to power 3. So out of this, if you now need to just consider LCM, so LCM we can just get as like 2's maximum power is 3, so you can write this as first term. 2's third power is 8. I will be directly writing 8 here, and next digit I am getting here 3. So 8 multiply with 3, that is 24. So 24 is your LCM, and that LCM is what? It's the total cells in Gantt chart. So this is how you can just consider the total cells into Gantt chart. So please remember this, how we have got. Okay. So for every task which is belong on your rate monotonic algorithm, you should consider this kind of assumption. So I have already drawn this one. So this is the Gantt chart we have with some 24 cells. Okay. So I hope it's visible now. Still okay. Now it's better looking. I hope it's visible. Okay. So what we can do is, we can simply now consider our tasks. So these are tasks. Let me just increase their size. Okay, their color also. So these are some 3 tasks. So these are being represented by P and E. So P is what? The period, like for how much time it will be executing. So we know that here T1 will execute for 4 seconds and it has highest priority. So 0 to 4 it will be treated here as like 4. You can simply consider like here you will have your T1. T1 will be present here. T1 will be here. Okay, because that has highest priority. Then next, after 4, it will be present again at 8. So I can simply just now type here T1. T1 with red. So this is your T1 at 8. I hope you can just see this. So why I'm writing like this? Because this is what a period. So period is what period I was just telling you here. Period is interval of time whenever particular job repeat itself. So what T1 will do? T1 will first execute for first 4 seconds. Then again it will execute for next 4 seconds. That's why I'm writing in Gantt chart. First it's coming for 4th, then again it's coming at 8 seconds, then again it will come at next 4 seconds, then again it will come at next 4 seconds. Like this it will happen. So after 8 it will execute at 12, then it will execute at 16, then it will execute at 20, and then at 24, like this. So this is the execution period of your T1 task. Similarly, if you will go for T2, so T2 will execute for how much time now? Just do check that the period is 6. So definitely T2 will be executing for first 0 to 6 is 6. So I will be just requiring T2. So just let me copy this, let me paste. This is T2. So I will be writing this T2 here. Let me take some different colors. So this is T2 or some other color. This is T2 for 6, then for 12, then for again 18, and then for 24, like this. So this is the time whenever the T2 is coming. Again remember, T2 has moderate priority, medium priority. Then we will consider T3. So T3 has period 8. So T3 will be coming here at this place. So you can simply consider this is now T3. So this is what your T3. So just let me take this one. It's not clearly visible. Okay, T3. So it's coming at 8. After 8 seconds, again it will execute at 16 seconds. Then it will execute at 24. So you can simply consider like it will come at 24 as well. Okay. So at last all the 3 tasks will be present. Okay. So this is the first term that we have, period. So we have drawn the period. Now what is next? Execution time. So for execution of T1, how much time it requires? It just require 1 second or 1 unit of time. Okay, for execution of T2, how much time it requires? 2 seconds. So T1 requires here 1 second, 1. T2 requires 2 seconds, and T3 requires again 2 seconds. So these are the time required for all the 3 tasks. So again note this, we need to remember this 3. Okay. So what task has your first priority? T1. So T1 will first come into picture, it will execute. Okay. And for how much time it's executing? Just for 1. So let me just take this here, center. Let me increase font size like this. Okay, so T1 is executed for first. Just remember one thing, like I have written somewhere, like every task executes only once in its period based on execution time. So if I am going to consider any task, let's say T1 as the one task which is executed. So this is what its period. So how much time or how many time it will execute in its cycle, that is just mentioned here. It's just telling it just executes only once. Okay, every task will just execute only once in its complete period. Okay, so here if the T1 is executed at just one time, so there is no chance like T1 will execute until and unless this T1 will not get finished. Till 4 seconds now, T1 are not allowed to execute because it has finished its execution time. Then what is next task that can be allowed after T1? Who has next priority? T2. So you can say now T2 will execute, and how much time T2 requires? 2 seconds. You have written here. So T2 will execute 2 times. Okay. Then next, what is left? T2 has finished its execution. T1 also has done. Then who is left? T3. So T3 requires how much time? 2. So you can write here T3 is coming here. T3 is also coming here. But you can see like as you are reaching at 4th second, T1 is coming into picture and T1 has highest priority. So here our this statement will execute, or this statement you need to just think about, that is what a higher priority task can interrupt lower priority ones. Like if I have some task with higher priority, that is T1, and T3 is coming, so T3 will preempt and T1 will come into picture and T1 will say ki I need to execute first. So here T1 will execute because this is now the period of T1. 4 to 8. So T1 executed now. Now next task can start executing. So what is next task? That is T2. But do check, like, do we have T2? No, because T2 has already in its cycle or in its period. So in its period, it's already executed. So T2 cannot execute. Remember this. This is important. So who can execute now? T2 is done, T1 is done. So we can think for last priority task, that is T3. And T3 needs to execute for 2 times. It has just executed 1 time. So now you can think to take T3. I hope you are understanding. Please understand this, like how we have done. We have taken T1, then T2 for 2 times. T2 has done its task, then we have taken T3. But T3 executed just for 1 time. When it started for execution of second time, T1 came. Okay, T1 came in picture, that's why T1 executed first. Then we thought, like, can we have T2? We could do that, but T2 has its period of 6. That's why T2 could not execute. Any task can execute in its period only once. That's why T2 could not execute. So we have taken T3. Okay. And T3 has also finished its execution in its complete cycle. This is the cycle of T3. Okay. Now what is left? This is now this one, like 7. So you can just think for, can we now take here any other task? Like, can we take T1? No, we cannot take, because T1 is already executed here in cycle. Then can we take T2? Yes, we can take, because T2 is just right now started. So you can take T2 is executed again, T2 is executed 2 times. Okay, so T2 has done its execution. Then here we have the task now T3 and T1. So out of this we know that who has the highest priority? Who has the highest priority? Just do check here. Like you might think here we will have, let's say, T3 or T1. So here you can see now what do we have? We have now T1. So you will simply allow now T1, because T3 is having least priority. So T1 will come again and T1 will execute. After that, we can think for next task, that is T2. So can we allow T2? No, we can't allow, because T2 is already executed. Okay, in its cycle. This is the complete cycle of T2. Starting from this to this, like 6 to 12. So T2 cannot execute. So who can come now? So T3 can come, because T3 started right now here and it will end here at 16. So you can say T3 will come and T3 will execute for 2 seconds of time or 2 unit of time. So T3 is executed. After that, who can execute? So you can just think now, T1 is executed in its cycle, T3 is also executed, T2 is not allowed. So here for this time, your CPU will be idle. So I would say this is the time when your CPU is idle. Okay, so you can simply say like this. Okay, the next is what? Next is now a time whenever we are talking about a next task, that is at 12. So at 12 we have T1 and T2 both are ready to come, but we know that T1 has highest priority, so T1 will execute again for how much time? Just 1 second. Okay, then T2 should come, so T2 will come and T2 will execute for again 2 seconds. Okay, then next what we have? We have now only T3 left. But do check, do we have taken T3? Yes, we have already taken T3. So we cannot take now T3 again. So again here CPU will be idle for this 1 unit of time. So we have done like this. Then next, at 16 unit of time or 16 second, T1 is again coming. So you can say T1 is executing again. Then can we have T2? Can we have T2 here? Just do check, like 17 and 18. We can't have T2 here, but can we have T3? Yes, we can have T3 here. Like you can just see now T3 is coming into picture. So you can take now T3. So T3 will come here. Okay. So I will write here T3 2 times, but you can see as I am writing 2 times here, T2 came. So T2 has more priority than T3. So here T3 will not come. T2 should come and it should execute. So T3 just executed 1 time and one more attempt of T3 is still left. So T3 executed, then T2 is now coming and T2 will execute for how much time? 2 times. Okay. Then next, what is left? So here again T1 came at 20 seconds. So I will say now T1 should again execute. Okay. So if T1 is coming into picture, now who is left? I think T2 is left. Okay. So T2 is executed. So it should not come. So who is left now? T3. So T3 is one instance is still left. So I will write here T3 only like this. So now do check like which task is left. Like I am at this place, this last cycle of T1. So T1 executed for one time. For this last cycle of T3, have we taken T3 two times? Yes, we have taken here two times T3. For this last cycle of T2, have we taken T2 two times? Yes, we have taken. So all the tasks are already done and these two fields are still empty. So we can say like all the tasks are executed in current Gantt chart according to our requirement and rest of the last two cells are idle. So for last two cells and last two unit of time, your CPU will be idle. So this is your expected outcome or expected Gantt chart. So this was your rate monotonic algorithm in RTOS. So I hope you are understanding this. So in next video, we will see again one more problem about this in very short way. So thank you.